This is a very, very powerful formula. We can use this in addition to law of sines. We use this when you're given either all three sides or if you're given two sides and an angle. If you're using here, if you're given like BC and the angle in between them, so side, angle, side. If you have side, angle, side, which is not the stinky example we had earlier of angle, side, side. If you have side, angle, side, you can use law of cosine. So here's basically your rule. If you have a right triangle, let me write these up here, kind of just a rule here. If you have a right triangle like this, your technique to solve will be psi y cos x, tangent is y over x. That's kind of your rule. You're going to use any of these or their inverses, or their reciprocals rather. If you have a right triangle, so that's example 1. If you have a right triangle, okay, so example 2, it's not right, so it's anything but right. It could be obtuse, it could be acute, doesn't matter, so it's not right triangle. Well, then you're going to look if you have a completed set, which means you have angle A here given, and you have side length A. If you have any completed set, you use the law of sines. Okay? Now, example 3 is a lot like example 2. So we have something that's not right, so something like this, but this time, what you have is you're given an angle, and you're given two sides. But they're not side A, so you have side angle side, side angle side. If you have that, you use law of cosines. That's how you know. So you're going to hear me a lot of the time say, is it right? Do we have a completed set? If it's right, we use psi y cos x, tangent is y over x. If we have a completed set, we can use law of sines, and that's only if it's not right that we'd use that. Otherwise, this is quickest. Or example 3 is if it's not right and we don't have a completed set, we use law of cosines. So now, after that introduction, let's see this. Oh, one thing, you could also have this, or I should put this, or you have a triangle and all you're given are side, side, side. Then you would also use law of cosines. Okay, so this one is that second example. It says, a triangle area of lawn has a sprinkler located at each vertex. If the sides of the lawn are 19 feet, 24.3 feet, and 21.8 feet, what angles of sweep should each sprinkler be set to cover? All right, so let's just draw this real quick. We have a yard that's triangular. We have something that's 24.3, something that's 21, so not quite as long, and something that is 19. Well, as I look at my drawing, it doesn't appear that I'm going to make this a little bit wider, make it easier to tell. We're going to make this the shorter side, and we'll just see how it turns out. I'm sorry about this, trying to get it all connected. To me, this appears to be the shortest, so I'll say that's 19. This is the middle, so this will be 21.8, and this will be the 24.3. 24.3 came across from B, 19 came across from A, and this comes across from C. So there's my drawing. What angle sweep should we be set to cover? Let's find angle A first. If I want to use angle A, I'm going to use the law of cosines because I have side, side, side. And again, that law of cosines, it says that A squared is equal to B squared plus C squared, so like the Pythagorean theorem, but minus 2BC cos of A. So I'm going to use that formula there. So do I know my A squared? I do. I have 19 squared equals, do I know my B squared? I do. It's 24.3 plus C squared. C is 21.8 minus 2 times B, which is 24.3, times C, which is 21.8, times, I'm running out of room here, the cosine of A. The cosine of A. Now, we could insolve this from here. It would definitely be the easiest way. But because I'm going to do the algebra here, what I would do is I would first subtract 24.3 squared from both sides. And so I need to subtract that over here as well. And so I'm left with 19 squared minus 24.3 squared minus that squared. That's what I'll have. Let's just go to the calculator and type that in. So I have 19 squared minus 24.3 squared minus 21.8 squared. Hit enter. I get negative 704.73. So I come back over here. Just know that I need to have done this on both sides. Let's just write that on both sides here. So I also would have subtracted that on this side. Okay, and so now what I'm left with is negative 704.73 equals negative 2 times 24.3 times 21.8 cos A. Now, to get the cos by itself, these are all multiplying over here. What's the opposite of multiplication? Division. I'm going to divide by negative 2, 24.3, 21.8. That's multiplication there. Negative 2 times 24.3 times 21.8. That should cancel that out. Let's go to the calculator. All I have to do is press divide and it'll automatically take my answer, which is there, divided by, actually, you know what, I'm going to do it this way so it doesn't get so confusing. Divided by negative 704.73 divided by negative 2 times 24.3 times 21.8. Before I press enter, I'm going to make sure those numbers are right. Yep, looks like they are. I hit enter, and now I get this value. So that's what I know is going to equal the cosine. And finally, to get the A by itself, I need to do the inverse. So I'm going to say that A degrees will equal cos inverse of that, which we just got in the calculator, but I'll just write it out over here. Negative 704.73 divided by negative 2, 24.3 times 21.8. Obviously, the negatives cancel here. Those would cancel out. So let's see if we do this cosine inverse of this amount, what we get. It's a trig, cos inverse. I'm going to go up and click our answer here. I get 48.3. Let's check our mode. We're in degrees. 48.3 degrees. So it's perfect. A equals 48.3 degrees. Now, you might be thinking, man, that kind of stunk. We got to do this for all of them. Well, we only actually have to do it one more time, and then we can subtract from 180 for the other. So what would be different to find angle B? Well, I basically do the same thing, except this time I will insolve. Since I did once by algebra, this next time I'll insolve. So this was angle A. We found angle A here. Let's find angle B. So here we would say that B squared, side length B squared, which we know what that is. That's 24.3 squared equals A squared, which is 19 squared, plus C squared, which is 21.8, minus 2 times A, which is 19, times the 21.8, times the cosine of B, and that's in degrees. There's our formula. All you do is it's kind of like the Pythagorean theorem, except you put the 2 that you have on the other side, and then you subtract by 2 times those 2 values in the cosine. So now we go to the calculator. I'm going to insolve this, and so I'll write in here what I'm doing. I'm going to go insolve here, and then I'll just do cosine of B like that. That's what I'm going to do in the calculator. And so we don't get confused, let me just kind of do a break here like that. And so let's go to the calculator and type this in. So you have menu 3.1, and we start typing this in. 24.3 squared equals 19 squared plus 21.8 squared minus 2 times 19 times 21.8 times cosine of B, and I'm going to put a degree symbol next to it. Close my parentheses there, comma, B. And it tells me that it's 72.7 degrees. 72.7 degrees. So we get here that angle B is 72.7 degrees. Let me check that one more time, make sure I don't make a mistake. Yep. So if that's 72.7 degrees, now to find angle C, you would just define C. What I'll do is I'll take 180 and I'll subtract 72.7 degrees, and I get 103.3 degrees, and then I subtract the 48.3. And when I do that, which this right here, and label this is subtracting angle A, this is subtracting angle B. When I subtract that, I'm left with, it looks like this is going to be 0.0 degrees. That's a 55 degrees even. So angle C would be 55 degrees. That's how you would solve this, and let's check it. The largest side should have the largest angle. The smallest side should have the smallest angle. The middle. That's true. So it worked out. We did it correctly. Now, here's one for you to try.